All right, in this video, we're just going to be introducing the concept of having an x and a y variable in a problem. And this is also going to really be introducing the concept of what's called a function. And we're going to be starting off by explaining what a function is. A function is like a machine. A function does something. Let's say, for example, we had some magical number machine that took whatever number you put into it, we'll call that number x because it could be anything, and this function doubled it or multiplied it by 2. Okay? That's what our number machine does. Then what we're going to do is we're going to say that this machine is the function of x. So the function of x is to double whatever x is. So if I said that x equaled 4, then the function of x would come out to be the function of x, meaning once we've performed the function of x, then the answer is going to be 8, or 2 times 4. Or if x equaled 13, then once we performed x's function, right, once we performed the function of this machine, then we're going to have 26, or double 13. Now, functions can be more elaborate. We could say the function of x is to take some number and multiply it by, let's say, 4. So 4 times x, whatever goes into it, and then we're going to add 3 to that. So now if I said, evaluate the function of x when x is 9. Okay, so when x is 9, what is the function of x? And you would say, okay, well, 4 times 9 is 36, and we have to add 3, so 39. This is all a function is. It's taking a simple expression, like 4x plus 3, and it's what we're doing is we're evaluating what the output of this expression is going to be based on some specific input. This is all that a function does. Now, we can use different ways to record this data, because let's say I gave you the function of x equaled negative 2x minus 5, okay? Now, I could say, well, what is x going to be? What's the function of x when x equals 3? And you would say, oh, okay, I can do this. Negative 2 times 3 is negative 6, minus 5 is negative 11. So when x is 3, then the function of x is going to be, what did I say, negative 11? Yeah. Well, okay, so that's really cool, but what if x is 4? What's the function of x going to be? And you say, oh, I can do that too. Negative 2 times 4 is negative 8, minus 5 is going to be negative 13. And I say, okay, well, what if x is 5? And you say, okay, well, negative 2 times 5 is negative 10, minus 5, hey, that's negative 15. And let's do one more for fun. When x is 6, we get negative 17. What I've done here is something important. I've created what's called a table. And the whole purpose of a table is to know what the function of x is going to be, to know what this is going to output for several different possibilities, right? And so let's just make a quick connection to real life. Let's say that we're going to put on a dance, okay? We're going to put on this function called a dance. We'll say the function of d. Why not? D for dance. And I say, okay, here's the deal. We're going to charge $5 a ticket. So however many people come in, which we'll call x, then the amount of money I make is going to be 5 times that, because I'm getting $5 for every person. So if one person comes in, I get $5. If 2 people comes in, I get $10, right? So then, we're trying to figure out how many people are going to come to the dance. number of people coming to the dance. And I'm sorry, you know what? I made a mistake. I should have written this as D to be consistent, not X. Not that it really matters, but we should be consistent. So 5D. And so a couple people on the dance committee went out. And one person said, hey, I kind of polled everybody, and I think there's going to be about 200 people coming. And then I say, okay, wonderful. Well, then 5 times 200, that means we'll make $1,000 at the dance. And then somebody else comes back and they say, I don't know, I talked to people, and I got the impression that there were going to be about 250 people coming. And I said, oh, okay. Well, then if 250 people come, we're going to make $1,250. And if 300 people come, right, then we're going to make what? That's going to be 300 times 5. That's $1,500. So what we're doing is we're creating a table to where we're kind of getting a feel for like, okay, you know, what's going to be our target? What's going to be our goal, right? If we know that the dance is going to cost $1,200 to put on, right? Then we say, well, we got to make sure more than 200 people come. If 250 come, we'll make a little, and 300, that'll be nice. We'll get a $300 profit after we pay for it. So making tables is not some weird thing. This is something that you do in real life to try and understand how something's going to turn out, right? Because a lot of times, just like in math, in life, there's a lot of variables. We don't know how many people are going to come. It's a variable. But we do, just like we said in the last video that introduced algebra in general, just because we don't know how many people are going to come doesn't mean we can't go ahead and do math, because we're going to do math with this function. No matter how many people come, we know our money is going to be 5 times that. So we can start to perform operations and try and be able to make sure that we budget correctly, right? So anyways, with all of that said, well, what if we want to know how much money we're going to make if 201 people come, or 202, 203? You get to a point where suddenly you say, wow, I don't want to make that many table entries, right? It's just too much to keep up with. And so what we're going to do is we're going to, instead of making a table, we're going to make a graph. And that kind of brings me over to my next point. A table is no different than a graph, except for a graph allows you to see a lot more than a couple of points. As a matter of fact, a graph potentially allows you to see an infinite number of points. So let's look over here. Let me bring a graph in real quickly. Here's my graph. What I'm going to do, I have in this graph 2 number lines. I have this number line, which on this number line, I'm going to represent x. And on this number line going up and down, I'm going to represent the function of x. So since our dance example had some really big numbers, to make life a little bit easier right now, I'm going to make a slightly smaller example. And I'm going to say we have some function of x that says, okay, all that we're going to do is we are going to say 2x minus 2. Okay? We have some machine that whatever you put into it, it doubles it and then subtracts 2. And so this allows me to say, okay, well, if my input is, let's say, I don't know, 1, right? So my input x is 1. This is 1 on the number line, right? 0, 1, 2, 3, 4. When I'm at 1 going left and right, where am I at going up and down? And if we put 1 in, we realize it's 0. So I'm actually right here. I'm at 0 on my output when my input is at 1. Well, what about when my input's 2? I say, okay, well, let's see. What's 2 times 2? That's 4, right? So when my input is 2, my output is going to be 4 minus 2, or 2, right there. When my input is 2, 1, 2, my output is 2, 1, 2. What about 3? Well, 2 times 3 is 6 minus 2, that's 4. So when I'm at 1, 2, 3, my output's going to be 1, 2, 3, 4. And when I'm at 4, then my output is 6. And we start to notice this trend, right? We can see that this is going up in a straight line. So we can draw this straight line and say, no matter what the input is, this line is really just a series of tons of little bitty points, right? And anywhere, no matter what my input is, I can quickly look and see what my output is. This is the point of graphing an equation. We take this basic if-then concept, right? If x is something, then what is the output? And instead of trying to manually write down every possible scenario, we're just drawing this line that represents all scenarios. And this allows us to visualize what could potentially be some pretty complicated things. And this is sort of the introduction to algebra, right? This is sort of the introduction to linear equations, where we have an input and we have an output, and we're trying to understand what happens depending on what goes into the problem. The last thing I want to point out is there's some terms, there's some words, vocabulary that we need to understand. And the two most important ones right now are slope and y-intercept. The slope tells us how much the output is going up or down based on what goes in. If we made this table here for 2x minus 2, we could pretty easily see, so here's x, here's the function of x. We could pretty easily see if I just had you plot 1, 2, 3, 4, right? When x is 1, the output's 0. We already showed that. When x is 2, the output's 2. When x is 3, the output's 4. When x is 4, the output's 6. We look at this pattern and we say, hey, every time we go up 1, every time the input increases by 1, then the output increases by 2. So we say that the output's going up 2 every time the input increases by 1. That's all slope is. You hear this referred to as rise over run because the output is our vertical number line. So how steep, how much is our line going up vertically or going down vertically every time we go over a certain amount? And so this is rise. How much did the height of the line change based on how much the horizontal distance changed? And you can see, this kind of goes back to simplifying fractions. You can pretty easily see that we could have looked at this, and I'm going to erase the table because we can look at this just purely from looking at the line. You can see that we went up 2 every time we went over 1, and up 2 every time we went over 1, up 2 every time we went over 1. Well, this is the same thing as saying we went up 4 and over 2, right? Isn't 4 over 2 the same thing as 2 over 1? So you know, this is showing that the slope of the line's the same no matter where we measure from, right? Maybe we're going to have to simplify it, but it's still 2 over 1 no matter how we measure it. We could have gone up 6 and over 3, yeah? But that's still 2 over 1. So this is slope. This is just how much is our output increasing or decreasing depending on how much we put into it. Now, the y-intercept is one other important piece of information. The y-intercept says, what is the output when x is 0? Okay? What does this function give you? What do you get out of this thing if you don't even put anything into it at all? And we'll talk more about why this matters in later videos. But looking here, when we're at 0, right? When we put nothing into this machine, 2 times 0 is 0. What's the output? Well, 0 minus 2 is negative 2. And visually, you can see that it's when x is 0, that's going to be where this line crosses the y-axis. This axis right here is called the y-axis. And by the way, a lot of times, instead of saying f of x, we'll just say y. But that means the same thing. So this line, when our function has nothing put into it, it's still outputting a value of negative 2. And this is y-intercept, is when x is 0, what does this function produce? So I hope that helps, and we'll move on to the linear. You need to go on and work on the linear equations module on Khan Academy. You'll find that under my website. Thank you so much.